Changing it.
Are we good? Yeah. Alright guys, before we get on to the search for life, we must go over Lee's and mine little presentation from last week involving water. Now, unlike the other articles that we were going over, we're talking about present day activity of water instead of just ancient. So we're really crossing a big bridge here. And what do I want to say?
They used the Mars orbiter camera on the Mars Global Surveyor. They took there's some images from like 99, 2000 of a lot of areas, and they went back and took pictures of the same terrains in 2006, 2007.
Is that for both papers?
Pretty much. I mean, they were similar.
It was along the same lines. Like the one paper, they didn't talk about that at all. They just talked about the gullies. But like in the other paper, they did see. They took the two sets of pictures and compared them and saw that there were changes in gullies. And like the other thing, like too, in the one paper, in the same pictures, they were able to identify recent impact craters. They found like 20. There were impact craters only on like on light terrain, so they could see the difference. And the whole evidence with that was that like the number and size distribution of the impact craters that they did find was consistent with what we assume that the modern day flux of meteorites is. So that was pretty much that whole line of evidence. They saw some craters and then hey, let's plot it on our flux chart, and it lined up perfectly.
Where at?
On Mars. It was really widely distributed. It was over light colored terrains, so they could really see the difference.
Okay.
So most of your outcrops of new water discovery derived from mid latitudes, which kind of reflects the stability of water. I remember we constructed the Mars phase diagram for water and established an extremely narrow window in which liquid water could potentially be present at current times. And just like that, you must consider the window that's established from the sun's solar heating on the surface of Mars, which, due to the tilt of the planet, you can only get liquid water present on mid-latitude regions facing the sun directly.
So yeah, the channels that they kind of found, this one paper, they were mostly they found most of them, they found a lot of them. There's like 90% were in the southern hemisphere, and they were above 30 degrees latitude, so obviously they're close to the poles. They were also on, most of these outflow channels that they found were on southern facing slopes, so they're facing the pole, so it kind of goes along with this whole poleward influx of water, I guess. So these outflow channels, they kind of break them into like three parts. I guess they divide them into a bunch of different categories, which are like extended, really wide and narrow, and it's kind of unimportant. But so they have like an alcove, I guess, at the top where the water comes out, and it removes material from the alcove, so you kind of have like a negative relief area. So it removes material at the top, and it cuts uphill. I guess you get your, whatever you want to say, incising of like a channel in your head alcove, and then it leads into like a really deeply V-shaped incised channel that leads down, and then you hit like a, what do they call it? The apron. So you get a depositional apron at the bottom where you kind of hit the bottom of your slope. It deposits all the material, and yeah, so like figure 2 on that paper. You can see an alcove where there's material being removed, and then there's a channel down the middle, and then there's an apron at the bottom where you get all your deposition.
Figure 2 on which paper? This one?
The evidence for recent groundwater seepage.
So, like Lee was talking about initially, was many of these modern Martian gullies were discovered upon discovery of new impact craters, which, let's see if I can make some sort of visual understanding. Basically, since MGS has been around for over 10 years now, it's kind of allowed for the ability to for us to analyze areas, come back, and readily identify what's new. So this is gonna be terrible. I'm sorry, guys, but let's imagine a fresh impact crater. Now, what they're seeing.
What do you mean by fresh?
Within the past 10 years.
Yeah, they were.
Okay.
And they know that because they
How do
weren't
they
there
know?
before.
Okay.
And these are areas that we have an inventory of information on. That was kind of the main part of one of these articles, is that we got new impact craters. So, in relation to
Where did they find the new?
areas above 30 degrees latitude, which, but the whole general pattern that we're seeing,
In the north, you mean, right?
yeah. The general pattern that we are seeing is the slope that's created upon new impacts is allowing water in the subsurface to be penetrated by sufficient solar heating to kind of create these little small deposits that kind of come out, form an apron, and terminate. Now, one of the general trends that we're seeing is that, let's just make up this crater, we'll call it Crater A. And Crater A, and we'll say this is the north side, this is the south. And let's envision the sun kind of coming from this general region. I know this is really weird, but you'll get where I'm going in a second. So what they're finding are these light-toned deposits that basically just move down slope and to a termination point, much like fluid water would behave. So many think that this has to be, melted subsurface water. And one of the other characteristics of this sort of discovery is that, sure, if your north end of a fresh crater has these deposits coming down because the sun is, forcing the melting and everything. You also have smaller gullies forming on the opposite side, which don't reach the extent that the other ones do. But that kind of reflects just like the sun's position relative to these craters. So in a lot of these samples, you're seeing this sort of pattern in which the north side is characterized by heavy gullies, I suppose you could say, larger ones.
Longer and they
And
more deeply incised.
But you also have smaller ones on opposing sides. If anyone actually has the present day impact cratering rate paper, Figure 5 is pretty excellent in describing what I was trying to show you guys in terms of light material being deposited on top of a fresh crater, like a dark material. And
How do you know that that's from liquid, though?
That's the thing.
I mean, it could just be slope failure, it could just be mass wasting.
Could be.
It could be totally dry and just falling.
Something like this definitely could be, but I mean, when you look, I guess they kind of interpret them to be the same thing that you see in these other ones, where there's there's a channel, and you're not really going to get a really steep V-shaped channel with solid movement.
And you get a lot of terrestrial landforms, not landforms, but just patterns of movement. You get sinuosity, you get meanders, and you also get various distributary channels.
These are all inside crater walls.
Crater walls and other sloping bodies.
Other places where you get a negative relief feature. They noticed a kind of trend with these features that they only occur when when you have a negative relief feature, some sort of deep canyon or impact crater that excavated enough material, and then so that these features, they kind of form around 200 meters deep, and deeper than the surrounding, I guess, where your base level is.
Mm-hmm.
So it's
It's also important to note that these Martian gullies from present day do not occur near volcanic regions or other endogenic heat sources.
Mhm.
So you can kind of rule that out as a possible influence on the situation.
What, did they talk about like freeze fall cycles or anything like that? Because you could have a higher rate of that on the northern slope that might cause more mass wasting.
I mean, I don't think they talk about it that way. I mean, obviously they suggested, this gases could be some sort of, solid mass wasting process. Liquid doesn't necessarily have to be involved, but I guess it's highly suggestive of liquid activity.
In the meandering thing, that's really
You
weird.
you get meandering channels in the depositional aprons.
You don't get meandering stuff from mass wasting.
Yeah, exactly. It's just going to deposit it. You're not going to be able to see a changing channel through the apron. It would just be there. But yeah,
Yeah, but
To get meanders, don't you have to have like some sort of continuous flow?
yeah, that's kind of what I was thinking too.
Yeah.
I mean, it could be continuous flow enough. They're not huge meanders. It's meandering to the point where it's like, okay, it's depositing to the right, and then it'll kind of flip over to the left or something. Yeah, like you can see them in some of the depositional aprons. It's not like a true river meander that we're thinking about. I mean, yeah, you see convergent channels, like these V-shaped channels combining to make even larger channels and stuff. I mean, it's really telling of liquid movement across the surface.
And they were able to determine that the impacts in relation to these Martian gullies that have been forming occurred between 1999 and 2006, just based on previous observation. So that kind of answers the question earlier. I was like, when did these happen?
And they kind of talked about ice damming. I guess I'll draw a picture on the board. Sure, check this real quick. But yeah, they talked about ice damming being probably the most likely reason why these occur like this. So here's your slope, I guess, like your crater wall or whatever. So you kind of get. They talked about how a lot of they said that the majority of these features there you can see layers, and then so in a single impact crater, all of these features originate at the base of one layer, which is really interesting. Obviously, so they're talking about okay, there's water coming up, maybe moving along the boundary between this layer, and then it hits here, you hit the edge of your crater, and it goes, okay, where am I going to go? Well, it can only go down. They talked so you get maybe liquid water moving along, maybe it's moving up, and then it hits a boundary of resistant layers, then it's going to move along here. So it's warm go ahead.
I was just gonna say you can see that out on 33.
I was just thinking of that. Where they get those icicles.
Exactly, you get them coming out of.
You don't get too
right
much
under the
actual
layer.
liquid water at the surface there though during the winter.
No,
cold.
not during the
If
winter.
it was super cold, you'd probably just get ice precipitating out.
Which is kind of where I'm going with this. So maybe you have the subsurface water flowing. Well, then once it reaches here, it's going to hit really cold and it's going to freeze. So you get an ice dam maybe in this boundary that holds back all the other water. So then you kind of get increased pressure and things like that. And then they talk eventually you might get increased pressure to the point where this ice dam actually breaks, and then you have liquid water and ice and all the eroded material flowing out, in kind of one little outburst. So then obviously then you get your depositional apron, which would do that. You kind of get an incised channel. And then that's kind of what they talk about. A lot of them are associated, you kind of have a dark terrain, and then you can see this light area that looks like some sort of outflow. They said it's either the deposition of ice, of frozen water, or it can be evaporated minerals, because we've talked about how any water that would be there would be really alkaline, have a lot of dissolved solids. That's kind of that whole deal.
What was their evidence on the heating from the sun? How hot do they think it would get? And does that really fit into